You see AI doing all this incredible stuff all the time, right? But have you ever stopped to wonder how it actually learns a new skill completely from scratch? I don't mean just memorizing data. I mean truly learning. It's a huge question, and the answer, well, it's surprisingly cool.
So, let's really frame this problem. How does an AI go from knowing absolutely nothing to mastering something really complex? Like a robot learning how to walk, or a system figuring out how to dominate a strategy game. It's definitely not as straightforward as you might think.
Some of the early ways we tried to teach AI, using techniques like policy gradients, honestly, they were super inefficient. I mean, think about it. We humans learn from instant feedback, right? That little voice that says, oh, that felt right, or nope, that was a mistake. But these early AIs, it was all brute force. The AI would try a whole long sequence of things and only learn from the final outcome. It was just painfully slow.
And this right here, this just nails the problem. Imagine a robot learning to walk, okay? It takes a really good first step, perfect balance, great form. But then, maybe 9 steps later, it trips and falls. Well, if you're only looking at the final outcome, the fall, the AI just thinks the entire performance was bad, including that perfect first step, so it actually learns not to take that good step again. You can see why this would be a terrible way to learn anything.
So clearly, that old way wasn't going to cut it. We needed a smarter approach, and that brings us to this really elegant solution, a method called Actor-Critic. It basically gives the AI an internal feedback loop, kind of like its own little inner coach.
All right, so first up, you've got the actor. Just think of this as the part of the AI that's actually out in the world, trying stuff. It's the one performing actions, exploring new ideas, and carrying out the current plan. It's the doer. Simple as that.
And for every actor, you have to have a critic. The critic's job is to sit back and watch what the actor does, and then evaluate it. It doesn't actually do anything itself. Its entire purpose is to provide feedback. It's the judge. And it's this conversation, this back and forth between the doer and the judge, that makes this whole thing so incredibly powerful.
Okay, but how does the critic actually make its call, right? It can't just give a thumbs up or a thumbs down. It needs a much better way to figure out the quality of any given action. And this is where a couple of key ideas come into play.
First, there's something called the value function. This is the critic's big picture take on things. It's not worried about a specific move, it's just looking at the current situation, the state the AI is in. You can think of it as the critic asking itself, all right, from this exact spot, how well am I likely to do if I just keep playing my usual game?
But here's where the real magic happens, the advantage function. This is so much more specific. It asks, okay, in this situation, was that one action you just took better or worse than what I normally expect you to do? It's comparing that one move against the average, and that gives you much more targeted, useful feedback.
This is a brilliant way to think about it. So let's say your goal is to learn the drums, but your current habit, your policy, is to just sit on the beach. Well, the value of that is 0. You're not getting any better at the drums. So actions like sitting on the beach or watching TV, they're exactly what's expected. They have 0 advantage. But what if one day you decide to actually practice the drums? Even if your normal policy is to be lazy, the critic can see that this specific action, practicing, has a positive advantage. It's way better than average, and it's the key to getting better.
Now, this is all great, but it kind of begs another question, right? How does the critic get so smart in the first place? How does it learn what's good or bad? Well, it has to be trained too, and there are basically 2 main schools of thought on how you do that.
On one side, you have the Monte Carlo method. This is a lot like that old, inefficient way we talked about. The critic waits until the whole game is over, looks at the final score, and then uses that one score to judge every single step along the way. Now, it's an unbiased view of what really happened, but it's super noisy because one lucky or unlucky move at the very end can totally throw off its judgment of everything that came before. Then, on the other side, you have the bootstrap method. Here, the critic judges step by step. It looks at the immediate reward it just got, and then adds its own guess about how the rest of the game will go. This is a lot less noisy, but it can be biased because the critic is trusting its own predictions, which might be wrong.
So what do people do in the real world? Well, usually they find a happy medium. Instead of looking just 1 step ahead or waiting to the bitter end, the critic might look, say, 5 steps into the future. It adds up those real rewards and then tacks on its estimate for everything after that. This approach, called end-step returns, usually finds that sweet spot between the noisy, perfect truth and the stable but potentially flawed estimate.
So let's put it all together in the actor-critic loop. It's this beautiful, continuous dance. The actor takes an action, the critic evaluates it, figuring out if it had a positive advantage. The actor then takes that feedback and updates its own strategy, making it more likely to try those advantageous actions in the future. And they just do this over and over and over. The actor gets better at doing, the critic gets better at judging, and you get this incredible upward spiral of self-improvement.
And look, this isn't just some cool theory stuck in a research paper. This is the engine behind some of the most jaw-dropping AI breakthroughs that we are seeing right now.
So when you see these advanced language models getting fine-tuned with our feedback, or you see those humanoid robots finally learning how to walk and handle objects, or an AI that can master an insane game like Go or StarCraft, yeah, under the hood, there's a really good chance that some form of an actor-critic algorithm is doing the heavy lifting. It's what makes learning in these unbelievably complex worlds actually possible.
And if you want to boil this entire thing down to just one sentence, this is it. It's really just a two-step process. First, learn to have good judgment. Learn to estimate what's good and what's bad. And second, use that judgment to do more of the good stuff. It's simple, it's powerful, and it just makes sense.
Which kind of leaves us with this one final big thought. We've figured out how to build an AI that can develop its own internal sense of what's advantageous, its own inner critic. But as these systems get more and more autonomous and start tackling more open-ended problems, the really crucial question becomes, how are they going to define what good actually means?